All right. What we want to look at today is we want to look at the idea of linear momentum. So to get a general idea of linear momentum, what we want to do is we want to start off with Newton's law, the second one, that the sum of the forces is equal to ma. Now, the first thing that we want to do is we want to remember that we define A as the change in velocity and some change in time. So what we can think about is that the sum of the forces is equal to m times delta v over delta t. Now, since we're going to assume that our mass is constant in time, so what we can do is we can put the sum of our forces and we can move the mass in here, and what we can say, or what I want to say, is that this mass is actually times, let's say, velocity final minus velocity initial over delta t. And then now we can take this mass and multiply it by both velocities. So now we have mv final minus mv initial over delta t. And what we want to do now is we want to introduce a new term. And our new quantity is called momentum. Momentum is called p, is labeled as p. It's a vector quantity, just like our velocity should have been. And momentum is mass times velocity. So momentum is a vector quantity, m times the vector v, and momentum can be thought of as inertia in motion. So because mass is inertia and v is motion. So if your object is stationary, it has no momentum. If v equals 0, p equals 0. So this new quantity inertia, momentum, if we put that in here, we get p final minus p initial over delta t. And then what we realize is we have the sum of our forces is equal to the change in momentum over the change in time. So the idea is that we can think of Newton's second law as also telling us that the forces acting on an object change the object's momentum. And so basically the forces are if you have forces, you have some rate change in your momentum. Now, so this is kind of like a byproduct of another way of looking at Newton's second law. And we said that this momentum is mass times velocity, which means momentum, if p is equal to mass times velocity, that means p has units. The units of momentum is got to be kilograms meters per second. And there is no, like I know, when we have force, we have it newtons, and energy is joules. Momentum is kilograms meters per second. It doesn't have any fancy or special unit. It's just mass times velocity. It is a vector quantity. And another way to think about Newton's second law is that that the sum of the forces on your object equal the rate change of the momentum. And we're going to explore this idea of the sum of the forces is the rate change of the momentum. We'll look at a bunch of different scenarios with that in some other videos. Now, in general, let me erase this. So we looked at the idea that momentum is mass times velocity. So let me write that over here, that p is equal to mv, it's a vector quantity. Then we had this idea that we can use the second law, the sum of the forces is now the change in momentum in time. So what we can do is we can think of we have two different cases. we have the first case would be if one condition would be if the sum of your forces is 0, if the sum of your forces equals 0, that means 0 equals delta P delta T, which means you don't change your momentum in time. In this case, you would say that your momentum is conserved. So this is the condition of conservation of momentum. When the sum of your forces equals 0, when the sum of the external forces on your object is 0, then your momentum, the rate change of your momentum, is constant in time. Momentum is conserved. The second case is when you don't conserve momentum and you actually have sum of your forces is delta P over delta T. And then the second condition is you have external forces. External forces. And then we're going to look at these conditions as well. So momentum is mass times velocity. It's a vector quantity. We can look at it from Newton's second law by looking at the sum of the forces, saying the sum of the forces is the rate change of the momentum. And then we have two conditions. One, if the sum of the forces is 0, then momentum is conserved. Two, we can sum up our forces and then we actually don't conserve momentum. We have external forces and our momentum is changing in time. And we'll explore these two cases more in detail